Hello and welcome to this video on iteration, which is essentially the repeated execution of sections of code. So we finished up last time with this multi-branch conversion utility, and we're just going to go ahead and delete all that code and start afresh for this one. So the whole point of iteration or looping, as I've already outlined, is essentially repeating sections of code. So it turns out this is actually more useful than you might initially think, and there are actually a whole bunch of situations where this is useful. For example, what if you want to do something until a particular condition is met? So let's say we have a program that needs to get input from the user in the range 1 to 10. Maybe this is some kind of rating system. We need to get a rating from the user from 1 to 10. If the user inputs 15, well, we kind of want to just get the input from them again because they've done it wrong. And actually, let's try and build a system just like this. So the first kind of iteration, or the first kind of loop we're going to look at is the while loop. And essentially, you just write the while keyword followed by a condition, just like you would for an if statement. And then you specify a block of code that you want to continually execute while the condition is true. So to start with, let's just get a rating value from the user like we did before. So we'll just have an int which stores the rating that the user input, and we'll just use scanf to get an integer value into that rating variable like that. And let's also have a prompt here, so we'll just printf enter a rating between 1 and 10. And then maybe we'll just have some conditionals in here too. So if the user inputs a value below 5, we can say something like, I'm sorry you've had a bad experience. If the user inputs 5, we can say, okay, thank you for your feedback. If the user inputs something above 5, we can say, I'm glad you enjoyed your stay. Let's say this is for a hotel or something like that. So we've already talked about if statements. We can just write the if keyword. We can formulate our condition. So if rating is less than 5, then we can have this block execute, and that can say something like, sad to hear you didn't enjoy the experience. And then we can have an else if, which is rating equals 5. And we can do our printf for that as well, which can say something different, such as thank you for your feedback. And then we can have an else statement, which says something like, glad you enjoyed the experience. So at current, this is sort of going to work. So we can open up our terminal window here, and we can compile and we can run our program. And it says enter a rating between 1 and 10. And if we play by the rules, this is going to work. So we can put 5. Thank you for your feedback. And oops, we should actually have some new lines in here. Let's just insert those quickly. Okay, let's save. Let's recompile. Let's rerun. So 5. Thank you for your feedback. We can go again. 10. Glad you enjoyed the experience. 1. Sad you didn't enjoy the experience. But actually then if we put something in here like 100, it's going to say glad you enjoyed the experience. Sure, that might be the behavior you want, but if you're recording these, so say this feedback is actually being recorded so you can review it at a later date and see what guests in your hotel enjoyed their experiences or whatever, then you really want guests to leave ratings in between 1 and 10. If they wrote 100, who's to say the cat didn't step on the 0 key, and actually they're meant to write 1, they really didn't enjoy the experience. Or maybe we just assume guests are kind of playing around if they put something like 100 in there. And actually, no, we want you to give a serious rating between 1 and 10. I don't want you to give me 12, I want you to give me a serious rating between 1 and 10. And we can use our trusty while loop to make this happen. If we go back to our code here, and let's just section off this portion here, because really this is the portion we'd want to repeat. So if the user enters a rating that isn't between 1 and 10, well, we really want to repeat these printf and scanf lines. So we re-output the prompt, and then we reread input from the user into our rating variable. So what we can do is we can form a while loop here. So let's write our while keyword, and then in brackets we write the condition that this loop depends upon. In this case, we want to keep prompting the user for inputs if the rating is either less than 1 or if the rating is greater than 10. And we've talked about that logical OR operator in the past to combine our conditions here. And then we just specify the block that we want to be repeated. So in this case, that's this block. And let's indent that code inside it just there to have clearer formatting. And on the note of formatting, you might note that actually my spacing between keywords and opening brackets can be inconsistent. So I've written if with a space behind the bracket just here, and I've written while without one just here. Really, that's probably actually considered poor formatting on my part. Maybe I should be putting a space here, or I should be removing these spaces down here. But you'll see people have different opinions on this. But back to our loop. Let's just try and step through what's going to happen here. So, okay, we start off, we've just entered our main function. We declare our rating variable, and then we go ahead and we have our loop. While rating is less than 1, or rating is greater than 10, we want to execute this block of code here. Now actually we have to be a little bit careful here because we can't guarantee that this condition is going to be met when we first bump into it. So if you recall, when we declare a variable, we don't have any guarantees about its value. It might just be the case that when we declare the rating variable, it starts off with a value of 5, and so, well, actually this means that this condition is going to be false because rating is less than 1, that's going to be false. Rating is greater than 10, that's going to be false. So that's going to be false or false, which is going to be false. So this entire condition is going to be false. We're going to skip this block, and we're actually not even going to execute that block once, let alone multiple times. So what we should do is we should initialize our racing variable to some value like 0. Now when we hit the loop the first time, we can guarantee this condition is going to be true because rating is going to be less than 1 because 0 is less than 1. And so we're going to hit this code in here, which prompts the user for some input and then takes that input from the user and places it in the ratings variable. Now what happens is when we hit this closing curly brace at the bottom here, because we're inside of a while loop, we actually spring back to the top here and we reevaluate this top condition. So okay, now rating has some other value because we've accepted input from the user into our rating variable. Okay, let's check the condition now. Now is rating less than 1 or is rating greater than 10? Well, if our user has input a value between 1 and 10, then we should see that condition is now false. So this time we'll skip past this block and then we'll proceed onwards. Otherwise, if the user has input a value that isn't within the correct range, well then that condition is going to be true. So actually we're going to execute this block again. People tend to find this a little bit confusing, but essentially all we do is we go through, we check the condition. If the condition is true, we execute the block. And then at the end of the block, we pop back to the top and we recheck the condition and see if we should execute this block of code again. This is really the core of the while loop. And actually the formatting is bothering me. I'm just going to add these spaces back in, but remember that really is personal preference there. And let's go ahead and compile this and see what happens. So if we compile it and we run it, okay, enter rating between 1 and 10, let's put in 5. Okay, thank you for your feedback, it just worked as it did before, but then if we run it again, and let's put in a value which is outside our range, like that 100 value. It's just prompted us for input again, and actually we can keep doing this, and it's just going to keep prompting us until we put a value within the valid range. And just so I can really demonstrate this iteration looping behavior to you, we're just going to hop over to Xcode for a second. And I'm going to set what's called a breakpoint at this line here. What a breakpoint is it means when I run this code within Xcode, it's going to just pause the code when we reach this line. So in this case, when we reach this line here, it's just going to pause execution and I can then resume it when I want to. So if I just hit run here in Xcode, okay, so we've paused on this line here. And actually we can see that the value of our rating variable is 0 at current. I can then step through the lines of the code, so I can say, okay, that's fine, go to the next line. All right, do the printf, that's fine, do the scanf. And we can see, okay, this is now like my console window down here, so enter a rating between 1 and 10. Let's say we put something outside of the range, like 100. And okay, you can see execution has now hopped back and my breakpoint got hit again up here. And we can see that the value of our rating variable is 100. So okay, if I now step to the next line of code, you can see, okay, we go back into this while block because the condition was true. Because 100 is greater than 10, our while condition was true, so we re-enter this block and execute it again. And again, we can just hop through here, and if we enter a value that's now within this, then we go back here, because we still have to check this condition to see if we need to execute the block again, and we can just step through that, and we go right over it this time, because 5 is indeed between 1 and 10, so the condition is false. We skip our while loop this time around, and then we head into our conditional branching, which in this case, yeah, we're going to hit this else if, we're going to go in here, we're going to printf that, and then we're going to go down to our return 0, just to end execution there. But let's go back to our text editor, and if we just get rid of this for now, another good application of loops and iteration is in counting. So say you wanted to print the numbers 1 to 100. Well, yes, you could have 100 printf statements, one that prints 1, one that prints 2, and so on. Or you could use iteration. So we could continually execute that printf line and have a variable which changes value, and we printf the value at that variable. And that might sound a little abstract to you, so let's actually do it now. So I'm going to create an int variable, and let's just call it I, and its starting value can be 1. So we declare a variable I, which is an integer, and we initialize it to 1. We're now going to create a while loop, and our while condition is going to be while I is less than or equal to 100. And then we're going to have our block, which we want to repeat. So what's going to happen here, if we just run through it at the moment, is that, okay, we're going to initialize I to 1, but then have a while loop that happens while I is less than or equal to 100. Well, if I starts at 1, that's certainly less than or equal to 100, so that condition is going to be true the first time around. And because we don't change the value of I right now, that's just going to be true forever. So we're just going to execute this block of code forever right now. So what we want to do is we actually want to increase the value of I each time we go around the loop. So if I write in here I equals I plus 1, then every time we execute the block, we're going to modify the value of I. So the first time around, I is going to be 1, we're going to execute in this block, we're then going to hit this line, I equals I plus 1. So that means if I is 1, I is now 2, we then hit this closing curly brace, we go back around to the top of the while loop. Is I still less than or equal to 100? Well, yes, 2 is less than or equal to 100. We then go back in here, we then add another one, so 2 goes to 3, and this repeats, 3 goes to 4, and so on and so on and so on, until we get to the point where, okay, I is now 101, so we go back round to the top, I less than or equal to 100, well, that's no longer true at 101, so we now skip this block, and then we go ahead and return 0. Now let's also just add a printf in here so we can see our value. So let's printf I, and let's make sure we have a new line there and save that. And what should happen here is we should find that this loops through 100 times, counting from 1 to 100. And of course we can try this. Let's open up our terminal window, let's compile and run, and hey, we get all these values outputted. And if I scroll through them, we can see that indeed we do get our output from 1 to 100. So it works. And by the way, a shorthand for I equals I plus 1 is I plus equals 1, which does exactly the same thing. So we can save that and compile it and run it, and that's going to be exactly the same. And actually a shorthand for that, when we happen to be adding 1 rather than some other value like 2 or 5, is we can just write I plus plus. And I plus plus, again, is exactly the same as I plus equals 1. Now, it turns out we could also actually write, instead of I plus plus, we could write plus plus I here. And in this context, they do the same thing, but they do have some differences to them. And actually, let's quickly go through those now. So quick diversion, let's just cut this code out and we'll come back to it in a second. If we have an int I, and let's set it equal to 5, let's say, and then we have some printf statements, and they printf an integer, and we'll just specify that integer parameter in a second. So our first one is going to printf the value I plus plus, and our second one is going to printf the value plus plus I. And actually, let's just have some printfs around these that don't mess around with our I variable, just like that. So we first print I, we then print I plus plus, which is going to modify the value of I by adding 1 to it. We then print I again, we then print plus plus I, which again is going to modify a value of I by adding 1 to it, and then we print I. So if we save that, and let's compile it and run it, you'll see that actually the output we get is 55677. So the first 5 makes sense because I is equal to 5, and then we print fi. We then printf I plus plus. Notice that this outputs 5. So when we use I plus plus, the expression has the value of I before we do the add 1, but we still do the add 1. So you can see that the next I output is indeed 6. And that has different behavior to plus plus I, because you can see we've gone from 6 to 7 when we print plus plus I. So when we do plus plus I, the prefix increment operator, because we call it incrementing when we add 1 to a variable. So our prefix increment operator plus plus I adds 1 to the variable, and as an expression has the value of the variable with the 1 added. And then we can see the printf after that, I is just 7. So I hope I made that clear enough, but essentially I plus plus, the postfix version, adds 1, but as a value gives you the value before it added the 1, and the prefix operator adds 1, but as a value gives you the value after it's done the addition of the 1, after it's done the increment. But anyway, that was a bit of a tangent. Let's just go back to our while loop, just like we had it before. There we go. And you can see how in this context, it doesn't matter whether we use the prefix or the postfix increment, because actually we don't use the value here, we're just using this as a statement. And of course we can just as easily make our loop count down from 100, so if in fact we initialize I to 100, and then we change our condition, so we want to execute this block of code while I is greater than 0, then all we want to do is change our update thing here. So instead of going from 100 to 101 to 102 through our loop, we want to go from 100 to 99 all the way down to 0 when our loop will end, and we'll skip past it and return 0. So to do this, we just want to subtract 1 from I. This is also called decrementing I. So again, we could use I equals I minus 1, or a shorthand for that is I minus equals 1, or a shorthand for that in this particular case when we want to just subtract 1 is our decrement operator. And just like our increment operator, we have both postfix and prefix decrement, which work much like their increment counterparts. So in this case, we can just use I minus minus. We can save that. Let's compile. Let's run. And you'll see that works just as you would expect it to. We go from 100 all the way down to 1. And if you're having trouble understanding that, try running through the code in your head manually. So, okay, I starts as 100. While I is greater than 0, well, yes, that condition is true, so we're going to execute the block, therefore the printf is going to happen, therefore we're also going to decrement our I value, we're then going to hit this closing curly brace, we're going to go back to the top of our loop, and I is now going to be 99 because we minused 1 from it, so okay, I greater than 0, that's still going to be true, and that's going to keep on happening. We're going to keep doing those printfs until we get to I equals 0 when we do our decrement, we hit the closing curly brace, we go back to the top, I is greater than 0 is now no longer going to be true, therefore we skip the block of our while loop and we go down, we return 0, and our program execution finishes. Now when we're doing counting loops like this, you can see we have a few different components involved. We have our declaration here, we have our condition of course for the loop, then we also have our update statement here to change the value of our variable to affect our condition so that at some point we meet the breaking condition to break out of the loop and stop executing the looped block. And C actually provides a shorthand way to do this. So if we just comment out this entire loop for now, and let's try and do exactly the same thing using a different kind of loop, the for loop. So the behavior of the while loop was, okay, while this condition is true, execute this block. And actually the behavior of the for loop is very similar, but instead of just having our condition in the brackets next to our while keyword, we have 3 sections in the brackets next to our for keyword. These are the declaration section, the condition section, and the update section. So if I just write out what this would look like, we write the for keyword, and then in brackets we write our 3 sections. So the first section is the declaration section. We then write a semicolon to separate it from our second section, which is the condition section. And then we write another semicolon to separate that from our third section, which is our update section. And then we specify the block that we want to be looped. And so essentially the way this works is that our declaration section is only going to be executed once before our loop starts. Our condition section is going to be used much like it is in the while loop as the condition that's checked every time to see if we should go and execute the block this time around. And then our update section is going to be executed after the loop each time. So to have behavior equivalent to the while loop that we've commented out above, all we have to do is in our declaration section, we can just declare a variable just like that. In our condition section, well, we can use the same condition that we did previously. And in our update section, well, again, we can just use the same thing we did here. We can just paste in our decrement here, and this is going to function exactly the same. And then we can copy and paste our printf into the actual body of the loop. And again, to be clear, this functions exactly the same. The first thing that happens is our I variable is declared and initialized to 100. We then check our condition I is greater than 0 to see if we should execute the block. If we should execute the block, then we go through, we execute the block, and when we get to the bottom, we execute our update statement, and then we pop back to the top to check this condition. This is exactly the same as the while loop version. The syntax of these 3 sections when each section executes can confuse people. So let's just compile and run this to prove this works the same. And there we go, we count down all the way from 100 down to 1. So just to make sure you understand the for loop, we're just going to formulate a for loop without its equivalent while loop. So let's write a for loop with a block that we want to execute 10 times. But instead of counting from 1 to 10, let's count from 0 to 9. So first of all, we write our for keyword, and then we start with our first section, the declaration section of the for loop, so we can declare a variable to use as a counter, such as our int I, which we can initialize to 0. We then have a semicolon, and we have our second section, which is the condition. So we want the block that we're going to specify to execute while I is less than 10. We then write another semicolon to separate our third section, which is our update. So every time we go around the loop, we actually want to add 1 to I. So we could write I plus equals 1, or in this case, we can just write I plus plus, and then we can specify our block. And then in here, let's printf our I value. So we want to output an integer followed by a new line, and that integer is I. And again, this should work exactly as you expect. So the first time we get in here, we're going to declare our I variable and initialize it to 0. We're then going to check our condition. Well, yes, 0 is less than 10, so we're going to execute the block. So we're going to do the printf. Then at the end here, we're going to execute our update statement, which is I plus plus. So I has now gone from 0 to 1. We then hop up the top to check our condition again. Well, 1 is still less than 10, so we're going to execute the block again, and so on, until eventually I is going to equal 10. Well, 10 is not less than 10, so that condition is going to be false. We're going to skip the block, and we're going to return 0. So let's compile this, let's run it, and you can see there you go, 0 to 9, just as we explained. And actually there are some keywords we can use inside loops as well. These are break, which actually functions a lot like break does in switch statements, and continue. And essentially when we have a break statement inside of a loop, it breaks out of the loop entirely, and when we have a continue statement inside of a loop, it just means that the loop will go immediately round to its next iteration, so it will go straight back to the top for the next iteration. It won't continue with the block. So to try and make the behavior of these clear to you, let's try and use them. Let's say first off that actually we want to count from 0 to 9, but we want to skip the number 6 for some reason. Let's say we're doing some calculation and we want all the numbers from 0 to 9, but actually we don't want 6. Well, what we can do is inside the body of our loop, we can have an if statement. So we can say if I equals 6, and then this particular block here is only going to execute within the body of our loop if I is 6. And within this, we can use the continue statement. So if we type continue and then a semicolon, this continue statement is going to apply to our for loop, such that if I equals 6, we're going to meet this conditional, we're going to enter this block here, we're going to execute our continue statement, which means actually we're going to skip the rest of this block, we're going to go straight back to the top. So what we should see here is that if we compile and run this, we get 0 to 9 outputted except 6. So if we compile and we run, you can see there we go, exactly as we would expect. So 0, 1, 2, 3, 4, 5, 7, 8, 9. So if we change this continue statement to a break statement and we compile and run that, what we should see is that instead of getting 0 to 9 outputted, we actually get 0 to 5. Because what's going to happen is when I equals 6 and we enter our loop block, we're going to meet the conditional I equals 6, so we're going to go inside of that conditional block. We're then going to hit our break statement, which applies to our for loop, which is just going to break out of the for loop entirely before that printf gets executed for I equals 6. So if we try this, we'll see that is exactly what we get. Now, of course, if you get confused in the logic of your loop and you end up with a condition that's never going to end, you get what we call an infinite loop. So let's get rid of this conditional break here on I equals 6, and let's change our update statement in our for loop to I minus minus. So if you run through this loop logically, I starts at 0, and then while I is less than 10, this loop's going to execute. However, each time the loop ends, what we're actually doing is minusing 1 from I. So I is going to go from 0 to -1 to -2, and so on, and our condition I is less than 10 will be true for a very long time. So if we actually compile and run this, we should see that we get a whole bunch of negative numbers for quite some time. Let me just end that immediately, but that did not end of its own causes. I had to terminate that program because it would have kept on going. Now, very occasionally people actually create infinite loops on purpose, usually because they're either expecting their program to be terminated by some other program, or because they have some kind of break statement inside of the loop that will exit that infinite loop in some particular situation. Common ways of creating infinite loops include while 1, because if you recall, the conditions in C are all based off 0 and non-zero values, and because 1 is a non-zero value, it is a condition that is always true, therefore this while loop will always execute. So if we try and output something like hello world in our while loop here, this is an infinite loop, so we should expect to just see that outputted for a very long time, just like that. I'm going to have to terminate that as well. And similarly, you can do the same kind of thing with a for loop. So if we actually use for here, but we don't specify anything for any of our 3 sections, so we just have 2 semicolons, then this should have the same behavior. There we go. Now there's actually another kind of loop that I wanted to discuss here as well, called a DoWhile loop. And this is a whole lot like a while loop, but you're guaranteed that the body of the loop is going to execute at least once, even if the condition is false. So if I actually just show you one of these, what we do is we type the do keyword, then our block, and then we type our while and the condition at the end. So something like this. So of course a loop like this is still going to be an infinite loop, so if we printf hello world, that's still going to be an infinite loop. Let's just test that out. There we go. However, if we change our condition, so actually it's while 0, a loop that should never execute, we'll see that actually our do while loop does execute once. And this is because the way it executes is it executes the block first, and then it checks this condition. And then if the condition is true, it goes back and executes the block. Otherwise, if the condition is false, obviously it's just going to go down and it's going to return 0. As opposed to a normal while loop, which checks the condition first before executing the block. So if we try this, we should see that hello world gets outputted exactly once. There we go. Now let's actually try and end this video with a useful example. So if we delete our do while loop here, let's try and output a multiplication table from 1 to 12. So if you don't know what a multiplication table is, the idea is that you have numbers going down and numbers going across, and then you can sort of find the cell where they intersect to find what the multiplication of those 2 numbers is. So this might be a slightly daunting task because we haven't really thought with iteration yet. But as a starting point, let's just try and output the numbers 1 to 12. So let's use a for loop for our counting loop, and let's have an int I which we initialize to, well, let's start at 1, and then we can have our condition. So we want to loop while I is less than or equal to 12, and then we have our update statement, and we just want that to increment I, and then we have our block, and then we should have a printf in here, which let's just printf the value of I for now, and then a new line, and this should count as we've done previously from 1 to 12. Let's just check it quickly. There we go, 1 to 12 as you might expect. And then the trick for a multiplication table is what we actually want is a loop inside this loop. Because for every number here from 1 to 12, we actually also want to deal with another set of numbers from 1 to 12 to do all the multiplications. So we want to have 1 times 1, 1 times 2, 1 times 3, and so on. But we also want to have 2 times 1, 2 times 2, 2 times 3, and so on. And you might be able to see how this relates to a nested loop. So if we try to do that, let's just copy and paste our for loop inside of itself here and indent appropriately. And let's rename our variable to j because we're going to have naming conflicts if we call them both I. Okay, so let's see what happens now. If we compile and we run, we see that actually we get each number outputted 12 times, and if you think about it, this makes some sense, because really what we've done is we've said, okay, for each number from 1 to 12, we want to loop 12 times and print that number 12 times. So okay, well that's a start. Let's actually just try changing our formatting a bit here. So if we change this \n to a \t, then we should see that after every number we have a tab space outputted, because \t is the escape sequence for a tab character. And then what we can do is actually down here we can do a printf that's just of a new line character. So actually what we're doing here is for every number from 1 to 12, we're outputting it 12 times, each with a tab space in between, and then after we do that we output a new line and then go to the next number between 1 and 12. And so if we try that, if we compile and we run, you can see, hey, we have a table. Sure, it's not quite what we want yet, but it's a good start. And actually, this is now very easy to get working as a proper multiplication table. If we change the number we printf from I to I times j, this is going to work as we intended. Because again, if you try and think it through, the first thing that's going to happen is we're going to have 1 times 1, and then while I is still 1, j is going to go to 2, so in that same row, we're going to have 1 times 2, and that's going to keep on happening until we get our new line. Then it's all going to repeat for I equals 2, j equals 1, I equals 2, j equals 2, and so on until we get to I equals 12, j equals 12. We print our new line, then we exit out of the loop and return 0. So if we try this, we can compile, we can run, and excellent, it works. This is a multiplication table. And again, just to try and dispel any confusion, if we copy paste our code and bring it into Xcode, and we can just add a breakpoint here and run. Then if we step through, and actually I'm just going to make this panel bigger so it's a little easier for you to see the values of I and j, and I can just step through, and we go through, and okay, j is uninitialized at this particular point, and then we go inside the loop, I equals 1, j equals 1, we then go through, we repeat this j loop 12 times, so 1 times 2, 1 times 3, 1 times 4, 1 times 5, and so on. Let's just keep stepping through, 1 times 10, 1 times 11, 1 times 12, and okay, we went past, we printed our \n, we then check our condition to see if we should repeat this outer loop again. But of course, first off, we do our update, so now I is 2, and yep, we went back in because of course this condition is still true, and then we go back into this inner loop, and now we're going to reset our j value to 1, and then we go back into our inner loop, so it's going to be 2 times 1, 2 times 2, 2 times 3, and so on until we run to completion just like that. So that is really all I wanted to discuss for this particular video. And again, as always, when we're introducing new very important concepts, I really recommend that you try and make some of your own programs that make use of iteration. Try and make use of while and for loops, and really try and make sure that you appreciate the way they execute and the way they repeat code until the condition no longer holds. So that is the end of this video, and I will catch you next time.